So in this video, I'm going to go over the study island problems that I kind of picked and copied or made a document for you guys to practice. So again, if we were in class, we would go over these together because I think these are some of the most challenging problems from the study island assignment, and then I would have you complete the study island assignment. So if you are thinking of working through that assignment on study island, this would be a good starting point. All right. I've taken the liberty of kind of going through and writing out all of the work beforehand just to make it easier for me to explain it so I don't have to write and explain at the same time. All right, so first problem here says you have a trapezoid and it gives you these measurements. And it's asking for the length of the median of the trapezoid, and median is just another word for midsegment. Okay, so we've talked about the midsegment formula. First thing you have to do here is draw a picture. Again, watch the order of your letters, E, F, G, H. You have to follow that order, or you will be filling in your your information incorrectly. To find the midsegment, you need the bases, right? That's all we need. So I think the most confusing part about this problem is that it gives you way more information than you actually need or will use. So as I'm drawing this picture, first of all, it tells you EF is a base, so you kind of know where to put those letters. So you know, like a base is either the top or the bottom. So the top is 4, and the bottom is 19. So if I add those together and cut them in half, I get 11 and a half, and that's my final answer. So I didn't use the 8, I didn't use the 12. I did nothing with this H and the altitude. So if that kind of freaked you out a little bit, like you don't even have to use that. So when you're solving these problems, just make sure you can kind of hone in on what exactly it is that you need. And if there's extra information, you can just totally ignore it. All right, next problem. Here we go. Okay, now this problem, there is probably like approximately 17.2 different ways you could solve this. So if you try this and you did it a different way than me, that's awesome. I feel like every time I go over this problem, there's a student who's like, well, I did it this way, and it's like a different way than I never even thought of. So I'm not going to go over all those 17.2 different ways that you can solve it. I just picked one. But we know it's a square, and we know that each side is 20. Now, there are lots of things we know about squares. So I started filling some of them in my diagram. First of all the sides are the same. They would all be 20. In a square, you have 4 isosceles right triangles created by the diagonals. So all of these angles are 45 degrees. That's true in every square. I know that the length of the diagonals are all the same. So that's why this, there's just so many ways you could solve this problem. But they want to know how long WU is. So I kind of focused on this big triangle here that's created, like half of the square. I know both of these sides are 20, so I plugged in a Pythagorean theorem, and if you work it out, you get 20 root 2. Now, you could also recognize this as, like I just said, a 45, 45, 90 triangle, so 20, 20, 20 root 2. That just follows that pattern as well. Now, the 20 root 2 represents the entire diagonal. They just want half of it, so then I just cut that in half to get 10 root 2. And if you don't like working with the radicals, you could do everything as decimals, and then when you have your final answer, just make all of these decimals and find which one matches, okay? One other thing that I didn't mention, but that I like to when we're going over study island problems, or any problems that are multiple choice, there are usually, at least two answers that you can kind of cross out from the very beginning that just don't even make sense. Clearly the answer would not be 20. So you could get rid of that answer. These 3 aren't quite as obvious, I wouldn't think. But yeah, that's just good test taking skills. Kind of just get rid of these answers that don't even make logical sense, right? Okay, next page. All right, so let's just go like this. Now this problem is just a bit of a doozy, which is obviously why I picked it, to go over it in class. We're working with an isosceles trapezoid. So right away that should cause some little bells to go off in your head. This means that your legs are going to be the same length. You could mark that in. Also, something that's true about isosceles trapezoids is that they have congruent diagonals. So this length here, KM, is the same as JL. So that's what I marked with these double tick marks here. And then I started filling my information in. JP is 90. KM is 234. As soon as I knew that, I just copied that down on this diagonal as well. KL is 102. That's the leg. So again, just boop, copied that right over. All right. Now it's asking for the length of LM. Okay. Now in this problem, you should see or pay attention to this right angle right here. Okay, anytime they're marking a right angle in a diagram, it's not like guaranteed that you're going to use it, but you should be a little suspicious of right angles, okay? Because that just means you have a right triangle, and you know right triangles are very special, okay, in geometry. So to find the length of MP right here, right, we have this little right triangle. So I did Pythagorean theorem with my leg of 90 and hypotenuse of 1 to 2. Bang, bang, got 48. Nice little number, whole number to fill in right there. Now, if this is a right angle, that means this is also a right angle. And we have another right triangle. I tried to go over these triangles in bold, just, you know, you could make them stick out a little bit and you can see them. But I have the 90, I have the 234. Just did Pythagorean theorem again. I got 216 for this guy right here. So when you add 48 plus 216, you get 264. Bang, bang, boogity. There it is. So that problem, again, if you didn't know that isosceles trapezoids have congruent diagonals, like you wouldn't have been able to figure that one out. But now you know, All right, next problem. I'm sure you guys could have figured this one out. The only thing that's confusing is that they're using Greek letters here to represent angles, alpha and beta, but that could just be like an X and a Y, so don't even be freaked out by that. But they gave us beta is 88 degrees and alpha is 31. This is a linear pair, so I knew that was 92. And you have to see this little right angle up in the corner. So if this is 31, that means this is 59. I've got a triangle, meaning angle 1 is 29 degrees. Okay, that was not too bad. Now the last problem here. Woo! This one's another doozy. Okay. And the reason why it's a doozy is because you're really going to have to draw on your Algebra 1 reserves that you have to solve this one, because you have to solve for x and y. If you have to solve for two variables, that means you're going to need two equations. All right, so let me explain to you how I came up with my two equations, and then we'll solve the system, a system of equations, together. Again, it's an isosceles trapezoid. So right away, that means these legs are congruent. I know this is really dark, so they have like lines here and also right angles. So hopefully you can see that, or if not, I just told you. But they gave us QR is 224, filled it in. RS is 35, so again, boop, boop, put that right over there, 35. RV is 21, so this line right here, which again you can't really see, that is 21. So okay, well, let's finish filling this in. ST, that's a whole thing here. That's your x plus 2y plus 56. I didn't fill that in. I'm just kind of like making a note of that. And QT, oh, QT, 1/5 x minus y. And that goes here. So there's our first equality. I know that 35 equals 1/5 x minus y, so I wrote that down. Okay. Now, for our other equality, we have to do a little bit of geometry. Okay, I know, shocker, right? Did not see that coming. This right angle, again, very suspicious, up to no good. But I have a right triangle here, so I set up Pythagorean theorem, and I got 28. So that 28 can go in both of these, like, measurements, both of those lines right there, 28, 28. This 224, I just copied it down, because that's going to be the same length from U to V. So now I can fill in my next equality. If I add 28, 28, 224, I get 280. That's the length from S to T, which I know is equal to this expression right here. So I made my next equation. Okay, let me just scrunch this up a little bit. X plus 2y plus 56 equals 280. I just subtracted the 56 from both sides to just simplify this a little bit. And I got my next equality. X plus 2y equals 224. I have my two equations. When you're solving a system of equations, hello, Algebra 1, there are three different ways 3 different methods you can use to solve. Substitution, elimination, and graphing. Okay? Now, I will say, this is multiple choice. So at this point, because you have the answers in front of you, you could plug your x's and y's in both of the equations until you find the answer that works. Okay? That's, totally legit. But I do want to go over how to solve this just because who doesn't love an Algebra 1 refresher? Okay? Now, I think the best method of solving these is elimination, and you know why that is? It's because they're both in standard form, okay? Is this all ringing some bells for you? So to eliminate one of the variables, I want either the x's or the y's to have opposite coefficients. It sounds so fancy. So to make that happen, I'm going to multiply this top equation by 2. Everything's going to be multiplied by 2. Okay? Now if you're like, why 2? You're going to see in about 5 seconds. So that's going to give me 2/5 x. I'm just going to copy it down here. Minus 2y equals 70. Okay, are you seeing it? So now if I add these two equations, oh, look what happens. Boom, gone. Okay, so if I add x plus 2/5 x, you can just do this in your calculator if you need to, but I know I'm going to get 7/5 x equals, and then 224 plus 70 is 294. Oh, look at that. Look how easily we can solve for x now. I'm just going to divide both sides by 7/5. Okay, and you get x equals 210. All right, and again, I can go to my answers. Oh, I bet it's going to be B. But once you have your x, you can plug it in to find your y. So 210 plus 2y equals 224. And then when you solve for y, you do indeed get 7. So there it is. Can you believe all that work that I would make you do? Unbelievable. All right, well, if you worked through this and you stuck with me to the end, way to go, kids. You're a champion. Thanks for watching.